Hello and welcome to the Chegg live stream. This is the Stoichiometry Office Hours edition. I am Alice. I'm going to be your hostess for tonight. We're going to be learning all things chemistry, all things stoichiometry. It is so great to have all of you all on here. If it's your first time, thank you for joining. We have office hours all week long for different classes that might interest you. If you're coming back, thank you for joining us again. Today, we're going to start with some warm-up problems and then go to some different categories. My name is Allison. I have TA'd for chemistry, organic chemistry, nursing chemistry. I've also tutored for chemistry and calculus, so I love teaching, love helping y'all better understand the content you're learning. Throughout this live stream, I'm going to encourage you guys to ask your own questions. If there's something you're confused about that you learned in class, type that in the chat. If you need some homework help, type those questions in the chat. That's what I'm here for. I want to help you all learn in any way that you can. And so I encourage you to just ask any questions you have. I also encourage you to actively participate. So we're going to start with some problems that I've wrote up, and I'm going to ask y'all halfway through problems to tell me maybe a smaller answer. Type that in the chat so we can make sure we're all being engaged and all learning everything. But with no further ado, let's get started with some warm-up questions. I wanted to start with a little bit more complex molar mass question. So first, we are going to find the molar mass of calcium chlorate. This is a fun one. I'm going to give y'all about 30 seconds to tell me what you would do in this instance. So kind of come up with a game plan of how we would solve this problem and type that in the chat. How would you guys solve this problem? So I'll erase that so we don't have any hints. About 15 more seconds. 5 more seconds, guys. 3, 2, 1. All right. So what we would start with is we need to go to a periodic table, and we want to find the molar mass of each individual element in this compound. So if I go to a periodic table, I'm going to find that calcium has a molar mass of 40.08 grams per mole. And there is one calcium in this compound right here. It doesn't have like a little sub prefix, so we are fine. We just know there's 1 mole of calcium. Now, we are going to go to chlorine, and chlorine has a molar mass of 35.45 grams per mole. Now, this compound setup tells us there's 2 moles of chlorine, and the way that we tell that is there's this little number right here, and that basically means we multiply however many of the elements in parentheses there are by that number. So if there's 1 mole of chlorine in the parentheses, we multiply 1 mole by 2, and we determine we have 2 moles of chlorine. And then we go to oxygen. And so oxygen has a molar mass of 16 grams per mole. Again, all of these molar masses can be found in the periodic table. It's that number with a lot of decimal points. That is your molar mass, or atomic mass. You might have it being heard like that. And so if we do 4 times 2, because we have those 2 numbers we have to multiply, we get there 8 moles of oxygen. And now we just want to multiply that across. So we have 40.08 times 1. So that's just 40.08 grams. And then we have 35.45 grams per mole times 2 moles. If we put that in our calculator, we're going to get 70.9 grams. And since we haven't done any like really big stoichiometry yet, this is just a little run through. If something's on the bottom, it crosses out with the top. So that's why our units in the end are only grams. And now we are going to go to oxygen. We have 16 grams per mole, and we have 8 moles. So we do 8 times 16, and I believe we get 128 grams. Again, the units are grams because the moles on the bottom cancel out with the moles on the top. our last step of finding the molar mass. Does anyone know how we find the molar mass? I'm going to give y'all 10 seconds. How do we find the molar mass of that compound? So we have all of the components in grams of the individual elements in the compound. How would we find the overall molar mass? All right, 3, 2, 1. If you said we add them all together, you're absolutely correct. So in my calculator, I'm going to put 40.08 plus 70.9 plus 128. I encourage you to follow along on these calculations. And if you put that in, you should get 238.98 grams. And if you got that, great job. Y'all are doing so good. That is the answer to the molar mass of calcium chlorate. If you're just now joining in, it is so great to have you. I'm Allison. I'm your instructor for tonight's Stoichiometry Live Office Hours. Throughout this live stream, I encourage you to ask any questions that you have. They could be homework questions you need help with, things you learned in class you're not quite sure of, conceptual questions, math questions, anything regarding chemistry. I'm here. I want to be a resource for you to learn. So anything you have a question on, ask, and feel free to actively participate in the questions we're doing. We're now going to move on to warm-up question 2, which is convert 38 milligrams of silver to molecules. So the way that we're going to do this is actually, I want y'all to come up with a game plan. You have 30 seconds again. Give me a game plan. How are we going to solve this problem? What conversions are we going to use? Any information that you think you would use for this problem, type that in the chat, and we will go over it in 30 seconds. All right, about 20 seconds, guys. What is the game plan? How would we solve this problem of going from milligrams of silver to molecules of silver? There are going to be quite a bit different transitions and different calculations in this problem. So if you have any idea of what to do, I encourage you to type that in the chat. You've got about 10 more seconds. All right, 3, 2, 1. If you said first we want to convert from milligrams to grams, you are absolutely correct. So we're going to start with 38 milligrams. And then we need a conversion from 38 milligrams to grams. So does anybody know that conversion? It is a little bit of a more easy one to remember, and it's one a lot of teachers require. So if anyone knows that, type that in the chat. If you said 1 gram has 1,000 milligrams, you are correct. Great job. And then we want to get from milligrams of silver to grams of silver. So, or next we want to get from grams to molecules somehow. There's one thing we need to do to get to the middle ground. Does anyone know that middle ground of how we get from grams to molecules? Anyone know? If you said we need the molar mass, absolutely. I tried to kind of give y'all a hint with that question we just solved before. So we're going to need the molar mass of silver. If you go on the periodic table, you'll find that the molar mass of silver is 107.86 grams per mole. So now we're just going to fill that in on our table. We have grams down here, moles up here. 1 mole has 107.87 grams of silver. Hopefully that's making sense. If you're getting lost anywhere in these calculations, just let me know, and I would love to better explain that. And then what is the last step to solving this? Anyone know? I'm going to give y'all 10 seconds. Tell me, what is the last step? How would we get from moles to molecules? About 5 more seconds. 3, 2, 1. All right, so we're going to need Avogadro's number, and that is how we get from moles to molecules. I'll draw a little diagram just to kind of give y'all a better visual. So we can go from grams to moles, and we can go from moles to molecules and molecules to moles to atoms. And if we want to convert back to any of these, let's say we want to convert from atoms to grams, we always have to go through moles. Moles is our middle ground for everything. So moles and that molar conversion is extremely important. So now taking that, if we want to go to moles to molecules, we have to use Avogadro's number. So does anybody know Avogadro's number? It's a fun one to memorize, I think. So if you know it, type it in the chat and you can kind of flex your knowledge on all of us. But we put moles on the bottom, molecules on the top, and 1 mole has, if you said 6.02 times 10 to the 23rd molecules, you are absolutely correct. So now, what we want to do is we want to put all of this in our calculator. And the reason I like to set up my calculations like this is because I can multiply directly across the top and divide everything on the bottom. So I would do 38 times 6.02 times 10 to the 23rd over 1,000 times 107.87. And I'm going to put that in my calculator. I'm going to give y'all 1 minute. Put that in your calculator. So I do 38 times 6.02 times about 45 more seconds. $15 seconds. Five, 4, 3, 2, 1. Okay, we have a really big number. If you put this in your calculator correctly, it should be, let's see, I'm gotta count all these decimals that I have. 2.12 times 10 to the 20th is what I got. So if that's what you got when you put in the calculator, great job, guys. That is the answer to converting 38 milligrams of silver to molecules. And that's the end of our warm-up. If you're just now joining us, it's so great to have you. I'm Allison, and I am going to be leading the live stream. I want to help you learn in any way that you can. So whatever questions you have, chemistry related, whatever stoichiometry, conceptual, anything from homework, things you've learned in class, I encourage you type that in the chat because I would love to help you with anything that you need. And until we have some questions in, we're going to go on and move to the gas law. We had a lot of questions about this last week, so hopefully this is helpful. If you need me to slow down when going over anything, let me know, and I would be more than happy to do that. But what we want to do now is label the variables P, V, and R and T that are in the gas law. The gas law, if you aren't sure of what that is this equation, PV equals nRT. It helps us find pressure, temperature, moles, volume of gas. Hopefully I didn't give away any of this question with what I just said, but I'm going to give y'all 45 seconds. Any variables that you know are labeled here, anything you know, if you know what P, V, N, R, or T stands for in this equation, type it in the chat. You've got about 30 more seconds, okay? If you know what any of those variables are, let me know. This is my favorite equation to use in chemistry because it's so easy and it's fun to remember. So if you know any of them, got about 5 more seconds. 1. All right, the P stands for pressure. The V stands for volume. So think of volume, liters, centimeters cubed, anything like that. Pressure, you can think of ATM, I think like kilopascals, stuff like that. For N, we think of moles. Moles are just moles, same units for everything. R is our gas constant, and its units are ATM per L over mole K. That's what we'll use for the purpose of this live stream. In Chem 1 and 2, I've never seen them really give R in another way unless they use like milliliters or something. But this is how the units you'll see the most, and that number is going to be 8.314. Just so we're all on the same page about the problems we're about to do, that is what R is going to be. There's different values of R as you change the units. This is what it is for tonight. And it is a correct value of R. I didn't just make it up. This is the number for ATM per L over mole K. And then T stands for temperature. Temperature, you can be given it in kelvins, Celsius, Fahrenheit. The main important thing about gas law is you want to make sure that your units for pressure, volume, and temperature equal your units for R, because everything won't cancel out if you don't have those units being the same. So now, knowing that information, let's move on to some math-related problems to the gas law and all those variables we just learned. How many moles of a gas are there at 248 Kelvin, 27 liters, and 0.41 ATMs? If you're just now joining us, it is so great to have you. This is the Chegg Stoichiometry Live Office Hours. I'm here to answer any questions you have. So anything stoichiometry, math-related homework problems related to stoichiometry and Chegg, or anything that you went over in class you're not quite sure of, type those questions in the chat. I'd be more than happy to help you, and it is so great to have you. We are working on gas law right now. So how many moles of a gas are there with these conditions? So does anyone have any idea for what we would plug in for what? Label the variables if you know what to label them with. I'm going to give y'all about 30 seconds and tell me how you would start by solving this problem. So how would you go about solving this? It's really important to know how you would start to solve a problem. I always tell my students that I TA, starting is the most difficult part. So knowing how to start, super important. Let me know, how would you start solving this problem? You've got about 10 more seconds. All right, 3, 2, 1. So first, what I would do is I would label my variables with the number that they are. So 248K is temperature, which is represented by T. 27 liters is volume, which is represented by V, and 0.41 ATM is pressure, which is represented by P. So then I'm going to write my overall equation, which is PV equals nRT. And then I'm just going to plug all those numbers in that I have. So pressure is 0.41, and I'll write my units below just so they don't get in the way of the numbers. V is volume, which is 27, equals N. N we don't have. N is what we're wanting to solve for because it says how many moles. So we know N is going to be our variable. That is just the letter and doesn't have a number to go with it for right now. N is what we're solving for. R, I told you guys earlier, we're going to be using 8.314 ATM per L over mole K for tonight. But again, there's multiple values of R. This is not the only correct one. Your teacher might require you to know a different one. And then last, T, we know is 248 because of what the problem says. So now what we want to do is solve for N. So the way I would do this is I would just divide everything by 8.314 times 248. This is just algebra, nothing super fancy with it. It's just manipulating the equation to solve for the variable you need. So I'm going to divide everything by those values. And then in my calculator, I would put N equals 0.41 times 27 over 8.314 times 248. So I'm going to give y'all about 30 seconds. Put this in your calculator. Let me know what you would get. And I encourage you to put this in your calculator because it helps you actively learn and remember what you're learning. So if you can solve these, you're basically a gas law expert and you're going to do great on that gas law chemistry test. So I'm putting 0.41 times 27 in my calculator, then dividing it by 8.314, and then dividing it by 248. So 15 seconds, type in the chat, what did you guys get as that answer? See if you can beat me to saying it. What did you get for that answer, guys? 5, 4, 3, 2, 1. If you said 5.39 or 5.37, can't read my calculator, times 10 to the negative third, you are absolutely correct, and that unit is moles. So 5.37 times 10 to the negative third moles. That is your answer. And that is exactly what you would say on a test to get full credit and get a good grade on that question. All right. Now we're going to move on to our next question. If you've just now joined the live stream, it is so great to have you. I'm Allison. I'm your hostess for the night. We are doing Stoichiometry live office hours. And any questions you have, homework related, or anything you went over in class that you're not quite sure of, let me know. And I would love to solve that for you. I'm here to help you learn in whatever ways you need. So any questions you have about stoichiometry or chemistry, let me know. We're now going to move on to our next gas law problem. So what is the temperature in Celsius of 16 moles of hydrogen at 0.3 atm and 15 liters? So how would you guys start solving this? I kind of gave y'all a hint with what we did above, but how would you start solving this problem? 10 seconds, how would you guys solve this? All right, about 5 more seconds. How would you guys start to solve this? 3, 2, 1. Okay, just like we did above, we're going to start by labeling the numbers to the variable they represent. So ATM cues us in that this is pressure. We'll label it with a P. L, which means liters, cues us in that we are doing volume. So I would label that with a V. Ooh. And then for moles, we have an N. And so the problem tells us that we have 16 moles. So 16 moles, that's an N. And then we're going to put our equation, which is PV equals nRT, and we're going to plug in for the variables that we have. So P is 0.3. And again, I'm going to put those units underneath. V is 15, just so we don't lose our spot. N is 16. Moles. R, again, like I said, R is 8.314, and that is ATM per L over mole K. And then for this question, we are solving for T. If you're just now joining in, this is the Stoichiometry live office hours. It is so great to have you. We're doing a gas laws problem right now. So we are solving for the temperature in this question. We are here so far. What is our next step in solving this problem? So I'm going to give y'all 10 seconds. Let me know in the chat, how would we solve this problem? All right, about 5 more seconds. 3, 2, 1. Okay, so we are going to divide everything by 16 times 8.314. 16 times 8.314. This will cancel out, and we're going to put it in our calculator. So y'all have got, let's do 20 seconds. Put it in your calculator. Let me know what you get. See if you can beat me to solving this. See if you can type it in the chat what the answer is before I say it out loud. All right, about 10 more seconds. See if you can beat me, guys. All right. 3, 2, 1. So we have temperature is going to equal 0.034 Kelvin. But if we go back to the problem, the question specifically asks us for Celsius. So, how do we get from kelvins to Celsius? If you're in chemical engineering like me, we have to do this conversion all the time. And I know in my chemistry classes, I had to do the same. So, this is an important conversion. How do we get from 0.034 Ks to Celsius? Does anyone have any ideas? All right, we are going to actually subtract 273. Kelvin to Celsius is a straight, direct calculation. It's just Kelvin minus 273 equals Celsius, or Celsius plus 273 equals Kelvin. They're off by a factor of 273. So if I put this in my calculator, 0.034 minus 273, I'm going to get negative 272 degrees Celsius. I don't know about you guys, but that is really, really cold. Definitely would not want to live in that cold of an environment. But that is the answer to that to that gas law question. If you've just now joined us, hi, I'm Allison. I am the stoichiometry hostess for tonight. We have these office hours every Wednesday. I encourage you to actively participate, ask any questions you have. That's what I'm here for. I want to help you learn in the best way possible. And now we're going to move on to rates. But if you have any of your own questions, feel free to ask me. I want to answer anything chemistry, stoichiometry related that you have. But for now, we'll move on to rates. What is the concentration of the molecules at equilibrium? If I start with 0.15 molar of each reactant, I'm going to give y'all 30 seconds. How would we start to solve this problem? We've had lots of questions on rates in the past, so I know this is something we sometimes struggle with. It's also a big thing my students that I TA struggle with, so completely understandable. It's a hard concept to grasp. But how would we start to solve this problem? Y'all have got about 15 seconds. Tell me, how would you solve this? All right. 5, 4, 3, 2, 1. Okay, we are going to use what's called an ice table. It's everyone's favorite thing ever. I'm just kidding. But basically, we label I, C, and E. The I stands for initial. So what we start with in this question, we start with 0.15 molars of each. C stands for change. So what is the change in the reactants and the products to get us to the end? How is that changing throughout our chemical reaction? E is equilibrium. So what is the molarity of those reactants and products at equilibrium? So I'm going to fill in what I know. But before we do any of that, I almost always forget. And this is like the biggest mistake, I would say, the most common mistake for chemistry students is starting off by balancing the question correctly. So we need to balance the equation. It is not balanced. So what we would do is we're going to see we have H2 over here and we have H2 over here. So two H's, that is balanced correctly. We have O2, two O's, but we have one O over here. So we need to make that a 2 so that we can have two O's on both sides, but now our H's aren't balanced. So we would just fix that by putting a 2 in front. So we have four H's, two O's. That is our balanced equation. Y'all are basically pros at balancing equations, I'm sure. But we would now need the initial, and the problem gives us that we start with 0.15 molars of each reactant. So in that I column for the reactants, I'm going to put 0.15, and I got that from right there. And then it says, it doesn't say anything about product, so I'm going to put 0 as starting out with 0 product. Then I need to figure out my change. For change, we look at the coefficients of the chemical equation, and we subtract or add based on if they are decreasing or increasing. So my reactant starts with something. I have to make my product out of something. So I know my reactant is going to decrease in molarity. It's going to decrease in size to create that product. So I'm going to do minus 2x. And x just represents that variable of change that we are not quite sure of. For O2, is also a reactant. We're creating our product with it. We have no coefficient, so we'll just do a minus x for that. And then our products, we don't start with any, but we create some. A chemical reaction isn't a chemical reaction if it doesn't create anything. So we know that that value is going to be plus 2x. If you're just now joining us, welcome in. We are doing a rate equation. So I encourage you, hop on in. If you have any questions, type them in the chat. I would be more than happy to answer your questions about this question or homework or anything chemistry related you have a question on. And now our last step is for equilibrium. We just want to bring these down. So we would do 0.15 minus 2x, 0.15 minus x, and just 2x. And the way I did that, bring top minus bottom or top plus bottom, and that is my variable. Then we want to find the concentration of molecules at equilibrium. I forgot to write this in here, but K is supposed to equal 1 in this problem, so our equilibrium constant is 1. So now I want to find the concentration of the molecules. The way I'm going to do that is a K equation. K equals the concentration of products over the concentration of reactants. So get that in your brain. That's definitely something your teachers will want you to have memorized. For the products, we know we have 2x. So we plug in everything we know. We know K is equal to 1. K equals 2x over the concentration of 0.15 minus 2x times 0.15 minus x. All right, and then we just want to solve for x. So the first thing I would do is I would use the FOIL method. So I would do 1 equals 2x over 0.15 times 0.15, which I'm going to need to put that in my calculator because I don't know that off the top of my head. But I would get 0.0225 minus 0.3x, which I got from doing minus 2x times 0.15. And then I would do minus 0.15x, which I got by 0.15 times negative x. And then plus 2x squared, which I got from negative 2x times negative x. Then I'm going to multiply everything on the bottom over to the left side. And I would get 2x equals 0.0225 minus 0.45x plus 2x. And now I am going to, or plus 2x squared. Oops. And then I'm just going to get 0 on one side of the equation so that I can use my quadratic formula. So I would just subtract 2x over, and I get 0 equals, let me put this in the correct order for the quadratic formula. That will be easier. So 0 equals 2x squared minus 2.45x plus 0.0225. And now I'm ready for the quadratic formula. Does anybody know what the quadratic formula is? All right, if you said x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, you're absolutely correct. That is the quadratic formula. So we're going to plug all those coefficients into the quadratic formula and solve for x. So we have b is negative. So negative times a negative is positive 2.45 plus or minus the square root of b squared. So 2.45 squared minus 4 times 2 times 0.0225. Just plugging in everything into that quadratic formula equation is all I'm doing right now. And then over 2a. So 2 times 2 is 4. I'm going to go ahead and put 4 there. Then I'm going to simplify what is under my radical. I'm going to give y'all about 20 seconds. Simplify what's under that radical. And I'll kind of write out the steps so we know what we're doing in a step-by-step way. So I would do 2.45 squared, 6.0025 minus 8 times 0.0225. I get minus 0.18. If I put that square root in my calculator, so 6.0025 minus 0.18, and I find the square root of that, I get 2.41. So I'm going to have 2.45 plus or minus 2.41 over 4. Now, with this, I'm going to have two options for an answer. I'm going to have a pretty big number around like 1 and a very tiny number that's going to be like 1/100th. So I'm going to go back to my problem, and I'm going to see what I said for each. I don't want this to be a huge number, because if it's a huge number, my reactants are going to have negative concentration, and that's just not possible. You can't have negative concentration of something. So I'm going to choose to solve it the way that would give me a tiny number, and that is using the subtraction sign. My chemistry teacher always taught me you can choose plus or minus, you can't choose both. So we are choosing minus because we need that small number so we don't have a negative concentration of reactants. So we would put 2.45 minus 2.41 in our calculator, and we divide by 4, and we get 0.01. If that's making sense, you can send a yes or a thumbs up in the group chat, just so I know that everybody is following along. But we are going to say x equals 0.01. And now we're going to go back into our ICE table, plug that in for all of our equilibrium values so that we can determine the concentration, which is what the question asks. Again, if you have any questions over what I'm going over, just let me know, and I'd be more than happy to help go over it in more depth. So 0.15 minus 2 times 0.01 is 0.15 minus 0.02 equals 0.13. And then, so our concentration of H2 at equilibrium is 0.13. Then I would do the same for O2. I would get O2 equals 0.14, and then 2 times 0.01, so many zeros. The concentration of H2O is going to equal 0.02. Send a yes or a thumbs up if you're understanding that. If not, we will go over it in more detail. Just let me know. If you're just now joining, it is so great to have you. I'm Allison. I'm your host of this live stream. We are working on stoichiometry and chemistry. Any questions you have, type those in the chat. They could be homework, things you went over in class. I'd be more than happy to help you. So I encourage you to type any question you have in the chat. And we are going to move on to limiting reactants, everyone's favorite type of problem. Just kidding. When I was in chemistry, I always dreaded doing these because they took so long, I felt like, but now I think they're super fun. And if you learn the strategy to solving for them, they're an easy, correct question on your test. So what's the limiting reactant if I start with 0.5 grams of each reactant? First up, we need to make sure of something. What do we need to make sure of? I'm going to give y'all 10 seconds. What has to happen before we can solve the problem? What do we need to check? All right, about 5 more seconds. 3, 2, 1. We need to balance our equation. Absolutely, you guys are correct. So we check and we see we have 1C over here, 1C over here. 4 H's, but we have only 2 over here, so I'm just going to add a coefficient of 2 in front of there because 2 times 2 equals 4. H's are balanced. O, we have 2 over here, but we have 4 on the right, so I'm just going to put a 2 coefficient there to make sure everything is adding up. So I'll check one more time just to make sure everything's correct. 1C, 1C, 4 H's, 4 H's, 4 O's, 4 O's. It is balanced, and now we are ready to start. How would we go about solving this problem? Does anybody know? Limiting reactant questions are a little tricky to start. It's almost something you have to memorize how to start. It took me many, many questions of limiting reactants before I realized how to do them. So let me know if you know how to start this. All right. Gonna go about 5 more seconds. 3, 2, 1. Okay, we are going to start with 0.5 grams of each reactant. So we have 0.5 grams of CH4 and 0.5 grams of O2. And the point of limiting reactant problems is eventually we want to get to moles of one product. So let's go ahead and pick a product now that we would go to moles of. I'm going to choose H2O just because I see it first. And normally whatever I see first is what I pick. There's not one option that's really better than the other. So now I need to go from grams of this methane, of this CH4, to moles of water. And how would I do that? Does anyone know how I would go from grams of methane to moles of water? I'm going to give y'all about 20 seconds. How would I do that? If you're just now joining, it's so great to have you. This is Chegg's Stoichiometry Live Office Hours. Any questions you have about homework, anything like that, anything you went over in class, any stoichiometry, chemistry question, fire it away at me. I would be more than happy to answer it. I want to help you in the best way I can. And I want this to be personal learning for you. So any question you have, let me know. So if you said we're going to go from grams to moles of our substances first, you're absolutely correct. So I'd put grams of CH4 at the bottom, moles of CH4 at the top. Same thing at the bottom, grams of O2 to moles of O2. And that's a really pretty easy conversion. I can just use my molar masses that I either create or get from the periodic table. So if we wanted to solve for the molar mass of CH4 real quick, we would just say we have 1 carbon times 12.01 is 12.01 plus 4 H's times 1.01 equals 4.04, and then we'd add them together and we get 16.05. So our molar mass of CH4 is 16.05 grams, is 1 mole of methane. Then if we went down to O2, which is oxygen, in its form that we find it, fun fact, those are any of our noble gases are found in pairs. So oxygen, chlorine, they're all found in pairs. So we would do O, so 2 O's times 16 grams per mole is 32. And so we'd have 32 grams in 1 mole. Now there's one more conversion we need to do here before we can get to our final answer. Remember, we want to get from moles of our CH4 to moles of H2O. We want to get to the moles of H2O to determine our limiting reactant. So I'd put moles of CH4 at the bottom, moles of H2O at the top. Same thing with the bottom, moles of O2 to moles of H2O. Now, does anyone know where these numbers that I'm going to plug in are coming from? This is a little bit confusing. I know a lot of the kids that I TA with, they struggle with this. So does anyone know where I'm going to get these numbers that I plug in from? Going to give you all about 5 seconds. All right, 3, 2, 1. So I would say I'm going to find them from that balanced chemical equation that we solved together. So I would do 2 moles of H2O on each, and that's because that coefficient right here is 2. And then for CH4, I'd have 1 mole of CH4 and 2 moles of O2. Again, grabbing those from those coefficients. If there's no coefficient, we use an imaginary 1 because we picture there's just 1 mole. We don't need to label 1. We can kind of infer 1. Same thing if you think about math with your coefficients of x. If there's just 1, you don't write a 1. You just assume it's 1. But now what we want to do is plug these into our calculator to figure out how many moles of H2O we created from each reactant. So for this top one, what I plug into my calculator is 0.5 grams times times 2 divided by 16.05. So I'm going to put that in my calculator now. I'm going to do 0.5 times 2 divided by 16.05, and I got 0.062 moles of H2O I'm going to do the same thing with the bottom. I have 0.5 grams of O2 times 2 over 32 times 2, and I'm going to put that in the calculator. Fun fact, if you get to this step and you have a 2 on the top and bottom, you can cancel them out because of the rules of algebra. Top and bottom cancel out. So really, all you have to put in your calculator is 0.5 divided by 32. I always find that's like a really nice way to simplify what I'm having to calculate, and it gives me less room for error when I'm solving a problem. So 0.5 divided by 32 is 0.016. So I have 0.016 moles of H2O from the O2. So with my CH4, I've created 0.062 moles of H2O. With my O2, I've created 0.016 moles of H2O. Which of these is the limiting reactant? Is it CH4 or O2? Y'all have got 20 seconds. Which of these is the limiting reactant? Let me know. Try to beat me to the answer. Try to say it before I say it so I can make sure we're all learning something. And if you're confused, how did I get here? Let me know and I will walk back through it. All right, 3, 2, 1. So the limiting reactant is whatever creates less product. Since our O2 created less product, it created 0.016 moles of H2O as compared to the CH4, which created 0.062 moles of H2O. Our O2 is our limiting reactant. We are about to the end of class or the end of this live stream. So any questions you have, now is your last chance to ask. I encourage you, any questions you have, let me know. We'll be doing this live stream same time next week. But we want to figure out, as our last bonus question, what is the electron configuration of mercury? So for this, I encourage you, pull up a periodic table. You're going to need the periodic table for this question. We've gone over electron configurations a few times in the past few weeks. So this is the challenge question. What's the electron configuration of mercury? I'm going to give y'all 1 minute to kind of figure it out on your own before I start writing it. See if you can beat me to solving it and type that in the chat before I get a chance to start writing it out. All right, let's see how well we have learned electron configurations. And this is a difficult one, so I will be very impressed if you guys can solve it. But I believe in you guys. All right, I'm going to start writing in about 15 seconds. All right, 5, 4, 3, 2, 1. All right, so for that first section in the periodic table, I'm doing 1s2. Also, I'm going to Hg if you're not sure the chemical symbol of mercury. And then I have 2s2 because I haven't gotten to my Hg yet. Then I have 2p6, still not gotten to my Hg. Oh, let's get that away. And I go to 3s2, 3p6, 4s2, 3d10, 4p6. Still haven't got to my Hg quite yet. 5s2, 4d10, 5p6, and then 6x2, 4f14, and then I get to 5d10, and that is my electron configuration for mercury. If you got that, great job. I'm so proud. We're at the end of tonight's live stream, but it was so great to have all of you guys on. I encourage you, same time next week, we will be streaming Stoichiometry live office hours. And there's also live office hours for other subjects all week long. So check out that schedule. You can find it on Chegg's website, or it is also probably somewhere on their YouTube. But it was so great to have you. Thank you all so much for joining. Have a great week. Bye, guys.